Good day, everyone. We are the Group 8, and our project proposal is entitled String Wave Machine. So proposal, this project proposal is a practical but easy machine to illustrate the concept of the wave motion, especially the transverse wave. Also, it gives a graphic display which allows the flow of energy in a medium without the properties moving around the place. Also, this equipment enables the learners to have a clear visualization between the relationship of the amplitude, the wavelength, and the frequency, which these are the essential concepts when we study the behavior of the waves. This project can help with a low budget, a hands-on research on the properties of waves by using basic materials, including wooden stands, a nylon string, and a DC motors. Also, it is helpful in teaching both classroom demonstration as well as laboratory works, since it allows the students to visualize scientific material, which is often hard to understand by theory alone.
Good day, everyone. The main objective of our project is to create a working string wave machine that helps illustrate how transverse waves move and behave. With this device, we can actually see how energy travels through a medium without the particles moving along with it. Through observation, we'll learn how different factors like frequency and tension affect the speed, shape, and pattern of the waves formed in the string. This project doesn't just help us understand the theory behind waves, but also encourage creativity and resourcefulness since it uses simple materials like motors, strings, and stands. Most importantly, this activity allows us to explore science through hands-on experience. By experimenting and observing real wave motion, we deepen our understanding of wave concepts that are often difficult to grasp through textbooks alone.
So today I'm going to present the concept of our project proposal. So waves are disturbances that carry energy from one point to another without transferring matters. Kabalo na tani no na, this means that waves move energy, not material or objects. So for example, when you throw a stone into the water, the ripples spread outward. No, the water doesn't travel with the wave, only the energy does. Okay, tanan na to na. For mechanical waves such as those produced by a machine that generates waves on a string, a medium is required for the wave to travel. So mechanical waves, basically they need a medium like air, water, or a string for them to exist. So in our project, the string serves as that medium. So without it, the wave can't form or propagate or move. In this project, the medium used is a stretch string. So the presence of a DC motor produces a periodic motion at one end of the string, creating up and down movement that form transverse waves. So the DC motor continuously moves and one end of the string up and down. So this repeated movement creates a transverse waves where the vibration is perpendicular to the direction of the wave travels. So just like waves you see on a rope when you shake it katato ang laboratory last time, no? Totong yan, ana ba kaya or up and down or from left to right. So ana na yung movement. So unlike sa longitudinal wave nga. Okay, so these waves can be controlled either by adjusting the motor's frequency or by changing the tension of the string. So in our case is ang tension sa string atong i-adjust. So we can control the behavior of the waves in two ways. So increasing the frequency makes the wave faster or shorter, or changing the tension or the tightness that affects the wave speed and pattern. So di man nato guro ma-adjust ang speed sa DC motor. So dito ta sa kuan. So that's why ang amo ang project or ang stand sa DC motor na lang atong i-adjust. So ano man yung forma, so atong close or na para adjust ang tension. So the movement of the string clearly shows how the energy travels through the medium and how the waves characteristics such as the wavelength and amplitude change depending on different external factors. So by watching the string move, we can see how energy transfers through it. So we can also observe changes in wavelength, distance between two crests, and amplitude, the height of the wave, depending on how fast the motor or is how tight the string is. So dito ta focus sa tightness, okay, tension sa string. So through observing the movement along the string, it is possible to note standing waves, nodes, and antinodes that are among the features used to explain the interrelation between frequency, tension, and wave speed. So when the waves reflect back, back and forth on the string, some points stay still and these are called the antinodes, the nodes rather. So while others move the most, which is the antinodes. So these patterns are called standing waves, and they help us study the connection between frequency, tension, wave speed, which is the main focus of our project.
For this project, we will need two pieces of DC motor, which is 25 each. So we have 50 pesos in total, and one piece of battery, that is DC powered source, that is 70 pesos, and two pieces of wooden stand that will act as support frames, that is 30 each. So we have 60 in total, and one piece of string or nylon, that is 27 pesos, and one piece of wooden base, that is 15 pesos, and lastly, two pieces of wires, that is 10 pesos each. So we have 20 in total. So to sum it up, the total cost of all these materials, these parts, is 242 pesos. And this is the apparatus parts or schematic diagram of our project.
So there will be 13 construction procedure that we will be having in our project. Number one, gather materials and tools. Wooden base, two wooden stands, two DC motors, nylon string, battery or DC power source, wires, screws or glue, tape, screwdriver, and wire stripper. Number two, mark and prepare the base. Measure and mark two mounting positions near opposite ends of the wooden base so the stands will face each other and the motor shafts will line up horizontally. Number three is attach the stands. Fix one wooden stand at each marked position on the base using screws or strong wood glue. Ensure each stand is vertical and secure. Number four, mount the motors. Place a DC motor on top of each stand and fasten it using screws, brackets, or strong adhesive. Align the two motor shafts so they are on the same horizontal level and facing each other. Number five, prepare the string. Cut a length of nylon string slightly longer than the distance between motor shafts so you have enough to tie nuts. Number six, tie the string to one motor shaft. Firmly tie one end of the nylon string to the shaft or to a small hook or coupling on the first motor. Double knot and trim any excess. Number seven, stretch and tie to the other motor. Pull the string towards across to the second motor shaft and tie it securely. Make sure the string is straight and free of twist. Number 8, check alignment and tension. Adjust the motor mount positions or stands as needed so the string is horizontal. Tighten the string to achieve moderate tension, not overly tight. Number 9, wire the motors to the battery. Strip wire ends. Connect one wire from a terminal of the left motor to one terminal of the battery, and one wire from a terminal of the right motor to the other battery terminal if necessary. Use connectors, switches, or clips for secure contact. Number 10, secure loose parts. Tape down any loose wires and reinforce motor mounts or stands with extra glue or tape if needed to prevent movement during operation. Number 11, power up safely. With fingers and loose clothing clear of moving parts, connect the battery or switch on the power to energize the motors. Number 12, observe and adjust. Watch the strings motion if waves are small or irregular. Slightly increase or decrease tension, check motor alignment or change the battery connection or motor orientation to adjust rotation, direction, or frequency. Number 13, turn off and disassemble. When finished, disconnect the battery before making adjustment or handling the string and motors. Safety tips, keep hair and fingers away from the spinning shaft. Start at low power, verify correct battery voltage for the motors, secure all fastenings to avoid parts being thrown during operation.